Well, I want to talk to you about 3D printing of houses out of concrete, obviously. But I know you mentioned that you're the director of the Virginia Center for Housing Research. And so I'm just kind of curious, maybe a good place to start this conversation is what is the state of housing like right now in Virginia?
Well, we have a lot of difficulty providing or building housing that people can afford or can even try to purchase at especially lower income levels, but increasingly housing is becoming so expensive that it's difficult for people who actually make quite a good living to afford new housing. And so, one of the ways that we've really tried to expand our economy in the past, or a big part of our economy, has been housing as an economic stimulant, as an economic indicator, things like that. And so, increasingly, as we can't build housing that people can afford to buy, we don't have that process of people purchasing homes. Now, we went through quite a period of people purchasing lots of homes, during the last five to 8 years. But if we can't get more people into housing that they can afford, we're going to see that we start to lose some of that economic progress.
And so with our challenges related to housing, are they primarily that we just can't build houses fast enough, or they're just too expensive for people, or is it a combination of both?
It's a combination of both. So part of it is that during the recession, we lost a large part of our labor pool. People who just said, there wasn't enough work, and when they left, they decided they were going to stay in another industry. They didn't really want to deal with this cyclical nature of the housing industry, right? It just kind of would be hot and then cold and hot and cold, and so people migrated away from the housing industry and residential construction. But then over time, as we started getting more demand, that was okay when we didn't have a lot of demand. As we started getting more demand, we found that we couldn't actually produce housing fast enough for the demand that we have now, for example. So we have a lot of demand, but also the cost of materials, the cost of that labor that it remained has continued to rise. We have high financing rates if you want to get a mortgage. We had, for a while there, especially less so now, we had a scarcity of materials and equipment. So you had these disruptions in the supply chain, which meant that people paid more if they wanted to get access to materials, and everything just kind of continued to rise. So the cost of housing now is much more than it has been historically, or it just continues to go up. A decade ago, the cost of housing was nowhere near what it is today. You couple that with the fact that everything else in our lives has inflated in cost in many ways, and we start to see that people are spending or being forced to spend somewhere around 30 to 50% of their income. The 30 is what we would consider someone who is getting a mortgage that they can afford, and that's about right. As we get up towards higher than 30, basically 35%, we start seeing that people are becoming what we call house cost burdened and are housing cost burdened. And so they don't have money for other things in their life that might be important. I mean, we're talking uh, trying to take care of their children, education, healthcare, transportation to drive to their work, things like this that become more and more critical that they can't spend money on. And as they get up to 50% of their income going towards their housing costs, it's really squeezing out a lot of the other items that they might need to spend money on. And so it becomes a real problem. And what we're also seeing is just the operation of the home. So the cost of energy that you need to pay your electric bill, as that rises as well, that is a housing related cost. So it just continues to squeeze people. And therefore, they don't have money to spend back into the economy or on things that are critical that they need. If you're a senior and you have a fixed income, it becomes even more of an issue. So we're seeing that all over, across the board, and it's something that we're really working on to try to figure out how to find ways to bring the cost of housing down.
Yeah, it does sound like a lot of problems. And as you mentioned, it sounds like it could be kind of a communal problem when you sort of talk about how much a person can give back into the economy and go to local shops and restaurants and that type of stuff. Well, I know I know that you laid out a lot of the problems, but I also know that you're working towards some possible solutions. And that's what I really want to talk to you about. When it comes to the 3D printing of houses using concrete, how did we get to that point? How did you get to that point? How did you start down that road as a possible solution.
We did a study a while back that looked at how much housing we would need in the state of Virginia if the economy continued the way it was. And right after that study, this was for the governor's office, we found out that Amazon was coming with HQ2, right? And that just changed a lot of the housing dynamics just in that one announcement there. We started finding that there was a lot of need for more housing now that we had more jobs coming. It was changing some of our economy, things like that. So our need for more housing versus the rate at which we could produce it. We were producing, and we're still not too much higher than that, about 20,000, 24,000 homes a year in the state of Virginia. Really, looking back 5 years, if we projected ahead to 2030, we needed to be producing between 70 and 100,000 homes a year if we were going to try to keep up with some of the need. And that does not include affordable housing, housing that people who make less than the median income can afford. So there's all kinds of different sides to this that we need to be thinking about. But at the time, we were asked, what do we need to do as a state so that we can try to increase the supply of housing? One of the things that we recommended, among many other, were embracing technology. So Virginia Housing, our housing finance agency in the state of Virginia, is very forward thinking, and they are looking at innovation, and they want to try to figure out ways to bring more technology and innovation into the housing supply chain. So they asked us if we would put together a team and purchase a 3D concrete printer and see how that could work economically and also in the application of it to building a home. Like what does it look like? Study that and then try to make that something that could continue beyond that, that could scale. That first project started in 2019, and the idea there that we're continuing to work with is we can take the exterior walls of a home. You can do the interior walls as well, but we wanted to just kind of isolate an area that we could study easily and that we could then try to replicate in other homes, but also that was pretty straightforward for the first few houses that we thought we could do it without too much complication. We could print these walls. We decided to take the exterior walls only and then compare it to what the cost of all the different materials, all the different trades, and the schedule might be for a similar house that's built out of stick framing or lumber. And so in that process, we're taking all these different parts of the home and we're basically reducing it to one main material and to one process, right? And we're hoping that by introducing some of these different technologies into the production cycle of housing, we can then reduce costs, right? So if we take all of that and kind of boil it down into something that's simplified, what does that look like? And so today, as a result of that, we've received further funding, and our new process now will take that from a site operation standpoint. And the goal is that we can basically create these pop-up warehouses where we can pre-print parts of the home, ship them out, stack them up, and you have the exterior walls, and we're kind of ready to go.
Wow. And so when it comes to when you did that analysis and the cost and stuff, how did the cost pan out for using just one material versus a lot?
Well, so you have to imagine that these are all prototypes. The first couple really would be prototypes, especially. So for the first couple, the first house, we had a lot of experimental cost in it. We were really worried about making sure that we had lots of people out there to be, to be on site for anything that might go wrong. It ended up, once you took some of those experimental costs out of it, it was about um, it was about $20 a square foot higher in terms of cost with the 3D concrete printing process. Then we were able to isolate where those costs were going. So, what is costing more? Why is it costing more? By the second house, we were faster. The process worked out a lot more, I would say. We were much more efficient. And by that house, we had gotten it down. What did I say before? I think I had said, well, anyway, we got it down to about 8% higher in cost in terms of stick built versus the concrete walls. Then we produced two other houses past that. This is the third and fourth houses that we've printed, and we're getting even closer than that. What we've eliminated are printing above the windows, for example, because it requires a lot of steel and there's a lot of cost in that. We're looking at eliminating printing below the windows, so we just have kind of a panel that slides in that contains the window, but it goes from floor to ceiling. and therefore we don't have to worry about the extra cost of printing below it as well and the details around that. We also are looking at trying to be much more transportable, and the cost of transportation is pretty high. And then we're trying to work on the cost of materials. If we can get the cost of materials down, it'll take a big chunk out of it. And so far, we found some options that should bring those costs down. So we won't know until after really probably the fall if this printing process ends up being less expensive than stick built, but we're hoping it'll come in somewhere close to kind of even, especially if we see the price of lumber rise. But right now, what I'm pretty comfortable telling people is we're about 8% higher in cost.
What are some other benefits? Like, were you all faster? Is it faster to do a house that way than it is a traditional way?
Yes, well, so we can print the entire house usually in about 5 days. Then we have to bring in the roof and we have the interior walls, but those go pretty quickly. And so what might take 3 to 4 weeks normally for that whole process and the different trades to come in and out, and it's getting weather the whole time, of course, we can do, in much shorter time. The other benefits are durability and how well it performs, especially if we're going to have natural disasters, long-term maintenance of the house. There's a trade-off there because it's difficult to sometimes to change up the floor plan if you want to because you've got concrete walls. But at the same time, it's not easy for it to be destroyed. You have to maintain it still, but it allows it to be a structure that hopefully will last for a long time and will resist high winds, natural disasters like fires, things like that.
Probably should have asked you this, but maybe I'm a little bit biased because I've seen some of your work in the past. But can you maybe just describe what it even looks like to see a house 3D printed? What is that process like?
Well, there's two different ways that we've been printing and that we've worked on building these houses. One is with a large gantry system, which is basically imagine an inkjet printer, but it comes, it moves vertically. So it has an X and a Y axis and then a Z axis. It moves vertically. And that process, you have to set it and it stays in the same spot, and then you print the house within the printable area of the gantry system. That's a great system. It's very sturdy. It also is very expensive to move because of the way that the print head works. You have a long distance of hose that you're working with, and so there are lots of possibilities of the hose getting clogged, or you're not moving the material through it very well, or that the difference between what you mix 100 feet away with, once it goes through the hose and it hits the print head, it'll be different when it comes out. So there are different implications for the printing process itself, but basically it just moves consistently to a certain height that you want to stop. And what we've figured out with some of those gantry systems is that we have specific stopping points as we go up. It'll just keep printing the entire house. With the new generation of equipment that we're working with, the robotic arm printer, robotic crawler. So it actually is on a tread base that will it can move and crawl to wherever you want it to go. It is much more precise. It's more sophisticated, I would say, in a lot of ways. Yet that also adds complication to the process. It's still you're printing it layer by layer, and you would have to stop it and move it in terms of printing it on site on the slab where you're going to be having the house. Whereas before with the gantry, it just stayed. It was, the print had moved, but the structure itself stayed. Very difficult to move, very expensive to move. The robot itself, it's easier to move. The technology's gotten better and faster and smaller, but you have to stop it and move more frequently. I think the side of this that we're excited about is that hopefully we can take this into a controlled environment. And one of the arguments that we've been wrestling with is why would you take something that really could be an automated process indoors with a controlled environment and stick it out into these elements out on the job site and have all the variability when it comes to humidity and temperature and sun and wind and all the things that are going to affect the concrete in the mix itself, which is really at the center of whether this works or not. Now we can go into a warehouse environment, we can control a lot of that. And so the variables or the variability that might affect our print are reduced greatly, is the hope.
Okay, so maybe you're printing at least pieces or maybe the entire house and then transporting it to where it will eventually be. Is that the idea?
Correct. So we'd have a set of modules, we'd have an exterior corner module, we'd have a straight run module, we'd have different interlocking details of those walls. But yes, we could print, and we're hoping we could print 5 feet at least, if not 8 feet, and then stack them up on site. We would basically pour some cores solid that would interlock them together, and then that would stabilize it. And then we go with the same system we had before, where we put a roof truss on the top of it and some interior walls made out of wood. All of that also, we're working on a system for pre-assembling all of that so that we can have a house shipped out and set up very quickly.
Yeah, so it sounds like you're not just trying to 3D print houses, but you're almost trying to research and create an entire infrastructure and system for how to do houses a different way.
It's grown, certainly. What started off as trying to look at ways to simplify the production process and bring down costs has turned into we can really work with what we're currently doing, and we can find lots of different ways to reduce costs and to make this more accessible to more people.
Yeah, that's awesome. Well, what are some of the key challenges? You mentioned the concrete mix itself and some of the elements, but what are some other challenges that you all are working to overcome in this process?
Well, one of the challenges always in this industry is people, right? So we can design it, we can engineer it as perfectly as we think it's going to work, and then we put people into the mix and it changes things up, right? So we're really working on understanding how automation, especially robotics, and human beings can work together. We want this technology not to replace human beings, but to amplify their capabilities. And we think the construction industry is a perfect place to do it. But we got to figure out how that's going to happen, and we got to work through some of the different sides to why we do things the way we do, and how can we make those processes better by using machines, really. And so right now it's, for example, working with a robot is quite dangerous, right? So what are the safety implications? What are the how many people do you need to really be working in an efficient way, but also a way that is safe and everybody is able to do their job as efficiently as possible, but also making sure that they are safe in the process. So that's one thing that we're doing right now. The other side of that is communications. Another side of that is just making sure that everybody knows what they're supposed to be doing, right? That we have standards for each section of the process, and that people are kind of sticking to some of those guidelines that we set, because the tendency is that people want to try to take something in the middle of the process and tweak it a little bit or do something a little bit differently. And I think right now part of our goal is to just set some basic standards that we know that will drive production, and then we start looking at ways to make it a little bit better here or there. But it's a it's a learning process every single day. So that's one of the things that we're working with. I think another thing historically has been trying to make sure that we fit within the code and that we make people comfortable with the product that we're trying to produce, and that that takes a lot of education. And so, getting out there and talking to people and helping them understand that this is actually a pretty straightforward process. It's pretty similar to what we've already been doing in a lot of ways. We've tried to create systems around it that don't make it more difficult for the trades to come in and run electrical lines, for example, or to place insulation in the wall, or we typically don't put plumbing or mechanical in the wall system itself. So we're trying not to affect too much of the process as we know it, so that people feel like there's a lot of risk and they don't want to do it. They don't want to be part of it, or they drive the price up for the part that they're doing anyway.
Yeah, well, as messy as I think concrete might be, sometimes I think people are probably a little messier. So that does make sense. We generally are sometimes the most complicated part of the project.
Well, yeah, and here's the thing. We have people who are making really wonderful robots, and they know how to make great robots. And we have people who are making wonderful buildings, and they know how to make great buildings, and they know the way to do it. Are they actually able to communicate how to make a great building with a robot, or how to make a robot that works well with people and buildings? That's what we're trying to figure out, how to be in the middle of that space and help bring both sides along, I think would be the way to say it.
Yeah, that's awesome. Bringing people together that have different interests, different expertise, getting them to work along better. That sounds like a lot of communications work that is right near and dear to my heart.
I'm sure, yeah.
Well, you mentioned some of maybe like the public perception piece, getting people comfortable with this. I'm curious if I was to live in a house that was built by this process, what would I notice that would be different from a house I built by a traditional process?
Well, we've been worried about what that might look like and how it could be different, and especially if it's different in a way people don't like, right? So one of the things that we were worried about, the first house we built was right on a major thoroughfare and a high speed street. I mean, the road was 45 mile an hour, I think, and cars would come by pretty fast, and we were worried about what the sound would be like. Right? Did it actually mitigate sound well, or inside the house, did it bounce the sound off the walls too much? So we worked with a colleague who developed a sensor system that could help us measure a lot of these different things we were worried about. We were really worried about concrete wicking moisture inside or not being able to actually release more. It would, if once we had a moist environment inside, it would actually wick that moisture, and then we'd have continued moist environment inside. And so we have sensors that look at humidity, making sure that it can hold the temperature well. We were worried. We had some people ask us, well, isn't it going to have gases coming off of it and chemicals and all kinds of different things? And which we didn't expect, but we also put some sensors in to kind of check to see if we saw that, that there were other types of gases in the environment. We also were really interested in daylighting, right? Because we were afraid they'd be kind of cave-like and people would feel like it was really heavy and in a large mass around them. And so we wanted to open the windows far enough that plenty of light came in, but not so far that, because we had concrete under the flooring, right? We had a slab as the floor, and it could warm up if we had too much sunlight come in. And then it kind of changed the way that we'd simulated how the interior environment should work as well with the mechanical system. So for the moisture, we put in multiple redundant systems with the first house. By the second house, because we had the data from the sensors in the first house, by the second house, we started being able to say, well, it's working pretty well. Let's take one of those systems away. And now we've gotten back to where it really, all the mechanical systems are the same as you'd have in a stick frame house, and they're working quite well. And just because of the detailing and the ways that we've learned from our designs, we don't see that it's building up moisture. We don't see that it's wicking moisture either. We have to be careful and keep moisture off of it. Don't get me wrong, but you have to do that with any house if you're trying to protect it well. In terms of sound, it's working quite well. We've looked at the sensors. It blocks out the outside. What we're hearing from homeowners is when they're inside the house, they feel like it's just quiet, right? It's this very quiet space that does not, you don't hear a lot of what's going on the street. You don't hear a lot of outside noise. You might hear some through the window areas, but not nearly as much as they're used to hearing in their other houses. The light works very well. They like the amount of light. In fact, a lot of the people, many of them have kind of levelers or curtains or blinds, so they block out the light because they like it kind of this nice controlled environment inside. The gases, we haven't seen as much of that, but we also monitored each house for energy use because we designed them to be highly efficient and high performing homes. And they have performed very well in terms of what we expected them to, how they should perform versus how the energy usage in the home is. Some of that, if it goes up, it's really based on occupant behavior. And we've been able to have conversations with homeowners saying, you could save more money if you didn't want to run this space heater or appliance or something like that. And we've been assured that this is just fine. We're comfortable with the amount of energy costs that we have. So we feel really good about that.
Yeah, I think I've had similar conversations in our house about ways we could save money. If
Turn
I
off
was also
lights
told
and
that I've also told we're comfortable with that in energy expenditures our house. So
well, we had one house that the energy bill was much higher than we thought it was should be. And we went and talked and said, you could save a good bit of money every month. And the homeowner said, listen, previously I lived in an apartment that was much smaller and I paid more energy costs. And I live in this house of my own now and I can be very comfortable and I don't mind. So we said, all right.
that's awesome, and I like that you addressed the lighting situation because in my mind I was wondering if it looked kind of like the Flintstones house, which was the only reference that I had. I mean, other people may not get that because I may be dating myself. My son's 6. He asked me who the Flintstones were the other day, and I was like, "Oh my goodness."
Well, I certainly get it. Yeah, I get the reference. Well, from a lighting standpoint, or just from the look of it, if you stand if you stand back from the house 10 feet or so, it looks a lot like clapboard kind of horizontal siding, with the striations in it. And once we coat it with paint on the outside and the inside, so we paint it on the inside. We try to have a vapor permeable paint, but on the outside we have a paint that will create a vapor barrier and a moisture barrier, and that smooths it out a lot in terms of the roughness of the concrete itself. People like the sculptural kind of structural look of it. It feels Still strong.
That's awesome. Well, I'm curious, I guess maybe to kind of wind this down. What do you think the future of building homes this way can look like? Or maybe what do you hope that it looks like?
I hope that we provide more options for the technology to be accessible, smaller, transportable. It is multifaceted and has, a multi-use capability. So it doesn't have to be that we are paying millions of dollars for these large factories so that we can set them up so that hopefully we can get some production and don't get me wrong, people are doing everything they can to produce as much housing and to do it at an affordable level today. The industry is working very hard and always has been very good at that. It's just not working the same way it used to be able to work because of the different costs and the different pressures on the industry. So if we can create technologies that are much more accessible to more people who want to build, and they can actually take care of more parts of the process, if that can also be then prepackaged or pre-assembled and then sent out, and it becomes something that's easily built across the country in areas where we have good distance to many different areas where we need housing, then we start seeing this infrastructure that can easily come into a community or multiple communities based on proximity and start really helping them with some housing options. We have the technology to make it very customizable now. It doesn't have to be what we used to worry about, which was houses that all look the same, kind of going up on 50 acres. We have the ability to make them look very different with the printing as well, which is nice. But we also have the capability, I think, now of making that much more accessible to more builders just from the cost of it as well.